All right, so today we want to talk about finding the derivatives of inverse functions. If we have a function, say we have a point, a function and its inverse always have corresponding points. So if we have a function, you can just call it f of x. F of x has the point 3, 9. Well, then the inverse function, which I'm just going to call g of x is guaranteed to have the point 9, 3. And actually, if we talk about these functions, let's say that the slope at the point 3, 9 is equal to 1/2. Well, the slope of the inverse function at the point 9, 3, that corresponding point, is just going to be 2. So if you know the slope of a function at a point, the slope of its inverse function will always be the reciprocal. And you can see that 1/2 is the reciprocal of 2 and vice versa. And another way to write this would say that the derivative of the inverse g is equal to 1 over the derivative of f at the inverse g. So let's go through an example. I think it'll make a little bit more sense. Let's say we're given f of x is equal to x squared, and g of x is the inverse of f of x, and we want to find g prime of 4. Well, we actually don't need to find the derivative to find g prime of 4. We don't even need to know what g of x is. We just need to have corresponding points. So let's find that. We know that g of x has the point 4, something. I don't know what that something is, but I know it exists. And we know that f of x must contain something, 4, right? At some point in time, this must be equal to 4. So we can actually set this equal to, we can set f of x, or which is x squared, must be equal to 4. So I set x squared equal to 4 because that's my f of x, and if I take the square root of both sides, I get x is equal to 2, and I realize this could be plus or minus 2, but just work with me here. We're just going to go with 2. So at the point 2, 4, and then at g of x, we have 4, 2. Well, now we know that f prime of x, we can say that f prime of 2 is equal to 4, right? If I find f prime of 2, it's equal to 4, and I know that because f prime of x is equal to 2x, and f prime of 2 is going to be 2 times 2, which is 4, right? So the slope of f prime of x is 1 over 2. The slope of the reciprocal, if this is the slope, is 4. The reciprocal at g prime of 4, I'm going to say sub m to indicate that it's the slope, is going to be equal to 1 over 4. I hope that makes sense. You see, we found our derivative. So I kind of going to write some steps out here. Steps to solve an inverse function. First, you're going to write down the points. I like to write down my f of x and my g of x first. And then I'm going to set points equal to f of x, right? So I'm going to try to figure out what that, I already have my y value. Hopefully, I have some value, and I'm going to try and solve that x value. Then I'm going to solve for x. You've got that step, solve for x. Then I want to find f prime of x. We're going to find our derivative. That's pretty simple to do. Then we're going to find f prime of whatever that missing point was, right? I'll just put this here. That was the missing value, that value we were missing. And finally, you're just going to find the reciprocal of f prime of that missing value. All right? So hopefully that makes sense when we kind of go through some in class, and of course I'll be there to help you. So now I want to talk actually about inverse functions, not just regular inverse functions, but inverse trig functions. You knew they were coming. You love trigonometry so very much. Here it is for you. So we have arcsine, arccosine, arctangent, arccosecant, arcsecant, arccotangent, and I will actually show you how to derive some of these, but for the time being, I'm just going to put them right here. Arcsine of u is equal to u prime over 1 minus u squared. Arccosine is negative u prime over the square root of 1 minus u squared. I think I forgot to say the square root up here. Arctangent is u prime over 1 plus u squared. Arccosecant, negative u prime over the absolute value of u times square root of u squared minus 1. Arc secant u prime of absolute value of u times square root of u squared minus 1, and arc cotangent negative u prime over 1 plus u squared. And you can see that these kind of partner up a little bit. They're very, very similar looking. So let's actually find some of these derivatives. So we have y equals sine inverse, which is the same as saying arc sine of 5x. Well, in this situation, u is equal to 5x, and u prime would be equal to 5. So if I'm going to find my derivative, well, y prime is going to be equal to 5 over the square root of 1 minus 5x squared, which you could rewrite as 5 over the square root of 1 minus 25x squared. That's it. That's the whole derivative. This is really kind of plug it in, solve it. It's not too complicated. Let's look at letter B here. Y equals tangent inverse of the square root of 2x plus 1. Well, in this situation, u is equal to 2x plus 1, and I'm going to write this as to the 1/2 power. So then u prime is equal to 1/2 times 2x plus 1 to the negative 1/2 times 2. Don't forget, you've got to take the derivative of what's inside there, right? So this is actually equal to 1 over the square root of 2x plus 1. Okay, that's my u prime. Now I can kind of dive in. Y prime is equal to 1 over the square root of 2x plus 1 all over 1 plus 2x plus 1. And this can definitely be simplified. And I get a lot of questions in class. When should I simplify? When should I not? Just keep simplifying, kids. I mean, this is a fraction over a fraction. That's kind of crazy. So 1 over the square root of 2x plus 1 times 2x plus 2. I would leave it just like this. I think that's plenty simplified. All right, let's do a little bit more complicated example. Here we have the tangent inverse of cosine of x. Well, our u in this situation is cosine of x. So u is equal to cosine of x. U prime is equal to negative sine of x. So our tangent inverse, or our derivative of tangent inverse of cosine of x, y prime is going to be equal to a negative, oh, I'm sorry, not there, a negative. So it's negative sine of x over 1 plus cosine squared x. That's it. Pretty simple. And finally, let's do one more here. We've got y is equal to sine inverse of e to the x. So u is equal to e to the x. U prime is equal to e to the x. All right. So y prime is equal to, if I go up here, hopefully you can see it here, my sine inverse there, is equal to u prime is e to the x over the square root of 1 minus e to the x quantity squared, which of course is just e to the x over the square root of 1 minus e, oops, I wrote this very poorly, but 1 minus e to the 2x. Good? All right, so far so good. Hopefully that makes sense. Now, if you feel like you understand this and you don't want to know how to exactly get these derivatives, you can stop the video right now. But I am going to keep going and show you how to actually derive these trig functions, these inverse trig functions. So, if this interests you, stay watching. This might be helpful just to know how to do. So let's say we want to find the derivative of sine inverse of theta. And sine of theta is equal to x, right? So sine of theta is equal to x. So sine inverse of theta is going to be equal to 0. So here we've got our right triangle set up. If sine inverse is x, it's going to be x over 1. So then our remaining side is the square root of 1 minus x squared. So sine of theta is equal to x. So then the derivative, I'm going to take the derivative of both sides. Cosine of theta times d theta over dx is equal to 1. So d theta over dx is equal to 1 over cosine theta. And cosine theta, right? Cosine is just going to be, oh my gosh, cosine, adjacent over hypotenuse. So this is going to be equal to 1 over the square root of 1 minus x squared. Hopefully that makes sense to you. Now I'm going to show you how to derive cosine inverse. So here again, you see we have our triangle. We want to find d of d over dx of cosine inverse of theta. So cosine of theta is equal to x. I'm going to take the derivative of both sides. So I get negative sine of theta is equal to, is equal to 1. That's true, but I forgot something. I forgot my d theta over dx. D theta over dx, that's equal to 1. I divide both sides, so I get d theta over dx is equal to 1 over negative sine of theta. And I substitute in for sine of theta, so I get d theta over dx is equal to negative 1 over the square root of 1 minus x squared. You can see that I pulled that negative up to our numerator. Finally, I just want to show you how to do this with tangent. The tangent of theta is equal to x. Derivative of tangent is secant squared of x, or theta in this case, excuse me. D theta over dx is equal to 1. So now we have d theta over dx is equal to 1 over secant squared theta. Substitute in, this is going to be d theta over dx is equal to 1 over 1 plus x squared. So hopefully that helped to clarify where we get these values from and what they really mean. If you have questions, leave them as comments in the video, and I look forward to seeing you in class. Goodbye.